All right, so I want to finish off the basics of loans by talking about interest capitalization, which is an unfortunate situation that does happen if you're not careful when you take out a loan. Hopefully, this doesn't ever happen to anyone. Uh, I mean, in a in a major way, but um, anyway, so. What is interest capitalization? Well, so sometimes even if you're making payments towards your loan, they don't even cover interest fully. So you have just interest that accrues and it just keeps adding to your outstanding balance. And that's called interest capitalization. It's when unpaid interest is added to your previous outstanding balance. Okay, so let's do an example to illustrate this. You take out a $10,000 loan, interest is 7%, and you want to pay it off in 3 years. Suppose you pay at the end of the first year $400. You pay nothing in the second year. And let's say you pay P at the end of the third year. Make an amortization table and find P. Also find P using an equation of value. So it is admittedly much quicker and easier to use an equation of value to find P, but I think it's still maybe a little more practical to make an amortization table just to kind of go through everything that's going on, getting the interest you owe, the outstanding balance, the principal repaid at the end of each year. Just getting those numbers gives you a better idea of what's going on with this loan, and particularly what happens when interest is capitalized. Okay, so here's a situation. Loan is $10,000, interest is 7% per year. The first payment is $400. The second payment is nothing, and the third payment we don't know what it is. Right? So let's just use our formulas to figure out, what P is. All right. So as I mentioned, we're making this amortization table to get a better idea of what's going on with this loan. So the interest you have to pay in the first year is 10,000 times 0.07. That's $700. And you'll notice something funny is going on with the formulas. And if this happens, it's good, to understand what's going on. All right. So the principal repaid at the end of the first year, well, it's 400 minus 700. That's the formula. You pay 400 as your first loan payment, but you owe $700. So this is going to be negative $300. Okay, and what that means is you're in the red for the principal repaid. So you're adding $300 to the principal that you originally owed, which was $10,000. Okay. So according to the formula, OB1, 10,000 minus the minus 300 makes it plus. So again, you're tacking on 300 to your outstanding balance. You owe more than you even originally owed when you first took the loan out. Okay. So what's the interest they have to pay in the second year? Well, 10,300 is how much the loan is worth. That's how much you owe. At the end of the first year, that accrues 1 year of interest at 7%, and that's 721. All right. So PR2, you're not paying anything in the second year. At the end of the second year, and you still have to pay $721 in interest. So you're paying negative $721 towards your principal. You're tacking on $720 to your principal. Okay. So again, that's reflected in the formula because we have a minus minus, makes it plus. 10,300 plus 721 is $11,021. Okay, and last but not least, that accrues 1 year of interest, which is $771.47. So whatever P is, your last payment, the amount that goes towards the principal at the end of the third year is P minus 771.47. You got to pay this interest off first. The rest, this whole thing goes towards principal. Okay, so dump into our formula for the outstanding balance at the end of the third year. 11,021 OB2 minus PR3, and that becomes 11,792.47 cents minus P. But the problem states that we're paying it off in 3 years. So that means OB3 has to be 0. We're paying off the loan in 3 years. So 0 is $11,792.47. Bring P to the left-hand side, and we get P is $11,792.47. Okay. So yeah. So your last payment has to be $1,792.47 more than what you took the loan out for. So just be careful. This was like a, like a 30-year loan, and you played games like this, really, paying minuscule amount of, making minuscule, loan payments, then interest will creep up on you and capitalize pretty badly. So be careful of that. Okay, and yeah, let's set up the equation of value. Right. The unknown is at the end of the loan, so let's set up the equation of value at t equals 3. So at t equals 3, well, basically that means since it's the end of the loan, we're taking the accumulated value of everything. Or rather, the accumulated value of the cash in equals the accumulated value of the cash out, time value. Okay. So the accumulated value of the cash in is just 10,000, 1.07 to the third. That accrues 3 years of interest, 1, 2, 3. And well, the 400, the cash out accrues 2 years of interest, 1, 2. I could have put a plus 0 here, but why bother? It's 0. So this accrues 2 years of interest. This accrues no interest. It's at the very end of the loan. So you just dump this into a calculator, take this 400, 1.07 squared, bring it over, and you get the same thing. So yeah, two different ways of doing the same problem. And again, this is much easier and quicker, but this really tells you each year what's going on with the loan. As I mentioned, for home equity purposes, for the purposes of repaying a loan sometime in the middle of it, for the purposes of knowing how much you can deduct from your taxes and interest, even just deciding whether it's better to take the standard deduction or to itemize and use interest towards your itemized deductions. All this, of course, is for mortgage. For all that, you need to know what the interest is, what the outstanding balance is at the end of each period. So, yeah. Okay, so one last thing before we end here. There's a problem with our formulas, and that is they're recursive. So I don't know if that's really a problem, but it makes it kind of a pain in the ass to utilize the formulas, particularly if you want to have amortization information, entries in your amortization table towards the end of the mortgage. Because towards the end of the mortgage, well, before I get to that, so in particular, all these depend on OBT minus one. OBT, oh, you need IT and PRT to get OBT. And to get PRT IT, the principal repaid at the end of the 10th year, the principal paid in the principal repaid, sorry, in the 10th year, the interest paid in the teeth year. You need OBT minus one, your outstanding balance at the end of the T minus 1 year. So if you, well, don't have it, yeah, sorry. If you go back here, you'll see that. For OBT, you need OBT minus one. For PRT, you ultimately need OBT minus one. And for IT, you need OBT minus one. You do need the payments, but those are usually given to you. Not always, but as an example we did before, they're not always given to you, but usually they are. But the issue here is that, let's say you have a 30-year mortgage and, I don't know, you want the interest earned in the 27th year. Okay. So to get that, you would need ultimately OB1, OB2, OB3, OB4, all the way up to OB26, the outstanding balance at the end of the 26th year. So there's got to be a better way to figure out what the interest earned in the 27th year is in a 30-year mortgage without having to do those calculations for 27 years, 26 rather. And there is, and we'll get to that in the we'll get to that in a video that'll be put up in maybe a few days.